Alright guys, welcome back to the second part of today's lesson. We just should have watched the video on preservation of equality. Essentially, to summarize that video, it means whatever you do to one side, you have to do to the other. Alright, what you do to one side, you do to the other. And so here what we're going to do this video is we're getting more into algebra, and we're focusing on solving equations, right? Solving equations with variables in it. Okay? And so the preservation of equality, what we just talked about, is still true even if, sorry, just so you can't really see that. There you go. Of the equation is an expression containing a variable. So even if one side contains a variable, remember a variable is a number we don't know, even if they contain that, the preservation of equality is still true. What you do to one side, you have to do to the other. And so what we have is we have a scale here, right? And on this scale, there's two variables, x's. We don't know what x's represent, but we know that it's the exact same number because it's equal, it's balanced, right? If it was not balanced, well, that wouldn't be possible. But let's say if I had a here, and a was higher in the air, remember that means there would be less stuff, and that this would be a bigger number. Bigger. Okay? But it's not, right? We have, erasing, we have them as x and x, so it's equal. They're the same variable, they're the same number. Okay? Here is how we kind of represent it using images. Okay? So what we have is we usually represent it using a square. The reason why we use a square is because it's an unknown number. We can use numbers when we know the number. For this we don't, or we can use a certain image. I'm going to be using a square. Once again, this could be 400 behind this box, right? It could be 400 of something. What we do know though is we don't know the number, but we do know that it equals on both sides. So here is an expression, 2x plus 3. By now we should know that this means multiplication when they're side by side. 2x means multiplication. And we know that this is going to equal to 9. Now we've talked about this before, but what we're going to do is we're going to discuss the preservation of equality. But we're going to look at the images first, and then we'll do this numerically. Alright, so this is the exact same equation. So again, 2x plus 3 equals 9. So we have our 2x. Alright, our 2x. So this, sorry, I should make it. This is an x, as we've established. This is an x, and these smiley faces are our numbers. Alright, what we're going to do is I'm going to use red highlighter to cancel out some images, and this is called balancing. Alright, I'm going to remove one of these guys. Alright, I'm going to remove one smiley face, but the preservation law of equality, I should remove a smiley face from where else? This side. Okay, what you do to one side, you have to do to the other. Remember our invisible force field, our barrier, it's right here. Okay, I'm going to keep removing these smiley faces until I run out on one of the sides. Alright, I've ran out. Alright, if we want to quantify this with a number, I removed, right, because subtraction is a removing, I removed 3 from this side, and I removed 3 from this side. Notice how what you do to one side, you do to the other. Now I'm left with 2 x's and 6 on this other side. So what I'm going to do is I'm going to break this because I want these x's by itself. I want to see how much does this box actually weigh. All right, I'm going to break these into 2 groups because if I break these into 2 groups, what do I have to do? I have to also break these into 2 groups. Okay, so now they're kind of linked up, they're paired. So this green, this one is paired with this one, and this one is paired with this one. Okay, what I just did is I broke them into 2, I divided them by 2. We only need one group though. Okay, we don't need 2 groups because we only want to find the weight. We don't want to find the weight of 2 boxes, we want to find the weight of 1 box. So I am going to follow this green because this shows me that 1x will equal to 3. Alright, if we want to write this over here, that means x will equal to 3. Okay? And we can do this by plugging it back in, letting the squares represent 3, and see if that also works out. So what we did, now with numbers. Oh, hello? Oh, I guess I didn't realize, but I crossed that out. I got the 2, right? And then from here, I split them into groups, right? Groups. And then we only want to keep one of them, so we can even number them. Let's say this is 1, this is 2, this is 1, this is 2. We only want to keep one of them, so I'm going to cross out the 2's. Cross that out because we don't need it. We're splitting it in half, just like you're sharing a Kit Kat. And then you're left with 1 equals 3. Alright, so that's a better visual representation. I forgot I did that. Okay? So again, we get to here. So remember, the first thing we want to do is we want to get rid of these extra numbers on one side. We want the x by itself. I need to remove this 3. Preservation of equality is what I do to one side, I have to do to the other. Alright, that's going to leave me with 6 in my bucket and 2x. I'll cross this off so you can't see it. Alright, so 2x equals 6. I need to divide this 2. The reason why I divide this is right now it's multiplication. I have to do the opposite of multiplication. What I do to one side, I also have to do to the other. So I have to divide this 6 by 2. 2 divided by 2 is 1, so I can rewrite this as 1x. 6 divided by 2 is 3, so 1x will equal to 3. And that's how we solve it out. Here's again, all this is talking about the preservation of equality using variables and how to express that. So this isn't about solving, but it's basically saying that if we start with 6 equals 3t, right, if that's what we start with, as we add plus 1 to one side, we have to do it to the other side. And this is how to represent it visually. Right? We started with this, we have 6, and we have 3 t's because we don't know their value, but we know they're equal, so they're the same length. That's why they're the same length. Okay, same length. Now if we add 1 to one side, we have to add 1 to the other, and it shows why. If we didn't add 1 to the other, this would be uneven lengths. So you continue to read this, it can help for sure. And if that's all you need to know, that's all you need to know up till now. The rest of this will be some extension, so you can go and attempt it, but the rest of this will also help you on the quiz. All right, so this is our extension. So basically, you can use variables to balance. You can use variables and images to balance it when there's 2 variables in your expression. All right, and we're going to show you using images how you do that. All right, so again, you have 2x plus 5 equals 7x. So what you're going to do, right? What you're going to do is, you notice how much you use squares. It's the same thing you've done before. All right, I'm going to pick one side. I'm going to cross out 1x until one side runs out of x's. All right, so what I'm left with is I'm left with 5 x's, and I'm left with 5 wholes. Now I'm going to break these off into groups. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I broke those off into groups. I realistically only want to keep one of those groups, so I'm just going to erase these so it looks a little bit neater. So I've already canceled this x and this x, this and this. Now I'm going to pair these off. So this one goes with this one goes with this one. These aren't canceling each other out. We've already divided, right? What we should have, if we've been kept following with the math, we divide this by 5. We divide this by 5. X should equal to 1. All right, so that's again with cancellation and pairing. So we can just do the math here really quickly. Right, we want to get rid of this 5. Sorry, we don't want to get rid of this 5. We want to get rid of this 2. All right, because we want one side to just have variables, and we want one side to just have numbers. So I'm going to subtract the 2. If I do it on one side, I got to do it on the other side. This becomes 5x and 5. I want only 1x. I don't want to know the weight of 5x's. this is multiplication right now, so I have to divide. I have to divide by the same. This will equal to 1. This will equal to x. X equals to 1. Alright, now with all that, you should be able to get up to here. And now this is our challenge question, is what does that last line mean? And so I'm going to do this with you. I've already started. Alright, the first one is you have 3 TIE fighters, 3 values that you don't know, but you know when you add them together, they equal 18. This could be their weight. Alright, so I did that by representing the variable, the unknown number, by using x. Another way of doing that is x plus x plus x also equals to 3x. Right? Because if you add 3 x's together, how many x's do you have? You have 3. Alright, that's going to equal to 18. Now, I have a multiplication, which means what do you think I should do? I'm going to have to divide. I'm going to divide this by 3, and then I have to divide the other side by 3. Right? The preservation of laws. If we're following along, or have been in this video, we know x will equal to 6. Okay? And you can do the math. You can re-put this in here as 6 plus 6 plus 6, and it does equal to 18. So we know 1 TIE fighter equals a value of 6. 6 tons. It doesn't really matter what it is. So that brings us now to, so that was stage 1. Let's go to stage 2. Okay? So we know that we can actually cancel this out now, because we know that this represents 6. So let's write this out as an equation. Do we, true or false, do we know the value for the Falcon? So I'm going to start this as 1. This will be 2. Do we know the value for the second spaceship? I don't know about you, but I don't know yet. Right? So we're going to, once again, say that it's going to be, let's call it a this time. A plus a minus 6 equals to 24. Right? We're minusing 6 because we already know the TIE fighter is worth 6. We can rewrite this as 2a, because there's 2 a's, minus 6 equals 24. Once again, we got a little bit of a problem here. Okay? We got to bring this over. So we're going to add 6. We're going to add 6. This is going to equal 2a equals 30. We're not done yet, right? Because we don't want to know how much for 2 falcons. We want to know how much for 1 falcon. This is multiplication, which means we need to divide. A is going to equal 30 divided by 2 is 15. Okay? That means 1 falcon equals 15. So I hope you're noticing a trend. Okay? So I'm going to quickly go through this. I think I've explained most of the math, and I'm just going to solve it now if that's alright with you. Alright, so stage 3. Stage 3, we have two X-Wings. I know we have 2 of them. I don't know what they're worth. They're called X-Wings. I've already used X. We'll put a Y. 2Y equals 8. Alright? That means we're going to divide them both by 2, because that's multiplication. Y is going to equal to 4. Alright, so this equals to 4. That's for number 3. Number 3. Number 4. Right, we have 2 values we know and 1 we don't. So let's put in the values we do know. Okay, so this TIE fighter, what did we say it was worth? It's worth 6. This Falcon, what did we say it's worth? 15. So let's write this out. So we have, this is a Star Destroyer, we'll call it D plus 6 minus 15 will equal to 1. Okay? What we need to do is we need to bring some of these over. We're going to bring over the 15. Okay? And then we're going to bring over the 6. So this is going to be first. The opposite of subtraction is addition. So we're going to have to add 15. Add 15. There we go. That's going to equal then D plus 6 will equal to 16. I gotta erase that so you can see it. We're not done yet, right? Because we want to know d. We don't want to know d plus 6. So in order to get rid of this, we need to, what's the opposite of addition? Subtraction. Subtract 6, subtract 6. That means d, right? What's 16 minus 6? It's 10. So d will equal to 10. So that means the Death Destroyer, Star Destroyer, is going to equal to 10. We know all of the values. Okay, so all we did is we started off with the number 1. We've solved each step, and for every new spaceship that was introduced and we didn't know, what did we use? We used a variable. Alright, so this is why it's relevant. It seems like a really good test question to me. Not with the images, but with any shape. Alright, we'll practice that more on Sunday. That was 4, so we're going to do 5. So 5 is going to be the answer. So finally, with 5, let's go back through our guides and see if we know all of these values. The X-Wing we said was worth 4. Then we said these are worth 10 apiece. We don't have any more unknowns, which is awesome. So 5 is 4, the last stage, plus 10, that equals 24. So what is that last stage? It's 24. Woohoo! I hope this isn't too confusing. You got an assignment to do as always. As per the post, we will have a test next Tuesday, a quiz next Tuesday. Right now, this is some extra practice to help you. Let me know if you have any questions.